Right, let's move on to question number 40. So this is the typical equation that we normally use to produce phosphorus. Okay, so this question is very similar to the one in 2019 as well, where there they ask the limiting reagent and the percentage yield, right? So let's go down to the question. So they have used 620 grams of calcium phosphide and 180 grams of silicon dioxide and 96 grams of carbon. And they saw 50 grams of P4 is formed during the process, right? And now they ask, under this condition, what would be the limiting reagent? So it is very straightforward. So if I directly write this here, this here, and this here. So carbon, the atomic number is 12. So 96 divided by 12 is 8 moles. So I'm not going to go down deeply because I have already done this in 2019, right? In the similar way, silicon dioxide, silicon is 28. O2 will be then 32. So 28 plus 32 is 28 plus 32 is 60. So 180 divided by 60 is 3 moles. Okay. And calcium 3 PO4. Okay, so phosphorus is 31. Oxygen is 16 times 4 is 64. 64 plus 31. So you need to calculate 64 plus 31 for the phosphate, one phosphate. So this will be 95 here. So for two phosphates, it will be 95 times 2. So basically it will be 190. Okay. And then you have 3 calciums. So another 120, 40 into. So you will get here 310 gram per mole. So 620 divided by 310 means 2 moles. Okay. So you can first calculate the number of moles very quickly because all values are given very straightforward. Then what you need to do is, based on the stoichiometry, you need to find the limiting reagent. That's the idea. So how do you find? So let's see. According to the stoichiometry, so if you have 2 moles of calcium phosphide here, calcium phosphate, you need 6 moles, which means like 3 times, because here 2, here 6. So 3 times of silicon dioxide is needed. Okay. So here you have 2 moles. So how much moles of SiO2 is needed if it is completely reacting? You need 6 moles, but you don't have 6 moles. You have only 3 moles. So at first point I see SiO2 is limiting here. Okay. And in the same way, if I try from the carbon point of view, so if you have 10 moles of carbon, you need 6 moles of SiO2. So if I have 8 moles of carbon, how I calculate the amount of SiO2 needed? So what you can do is you can divide this 8 by 10 to check for 1 mole of carbon. Okay. And then you need to multiply this by 6 basically to calculate the amount of moles of SiO2 necessary for complete reaction. So this will be 48 divided by 10 means 4.8 moles. So do you have 4.8 moles here? No. So from the calcium phosphate perspective, as well as from carbon perspective, we see here SiO2 is the limiting reagent. So this is very straightforward to find the limiting reagent. Then you need to calculate how much phosphorus would be formed if SiO2 is limiting. So SiO2 limiting mean SiO2 is going to completely react here. That's the idea. So if SiO2 is going to completely react here, which means here the stoichiometry is 6:1 with this P4 molecule. So if 3 moles of SiO2 is going to react, how much moles of P4 is going to form? It would be 3 divided by 6 because the stoichiometry is 6:1. So basically, there will be 0.5 moles that is going to form. And these two, some amount will be reacting based on this, and some amount will be remaining in the mixture. Okay, so we are not worried about that. So then what you can do is you can find the mass of P4 that is formed, mass. So it will be half, which means 0.5 into P4. So P4 is 31 times 4, which is 62 and 124. So mass should be formed is 62 grams of P4. So remember, this 62 gram is the theoretical amount that should be formed, right? Based on the amount of reactant and the stoichiometry. However, they have given the real amount formed in the practical experiment, that it is 50 gram. So how do you find the percentage yield here? So percentage yield of P4 will be equal to the real amount that is formed, which is 50 gram, divided by the theoretical amount that should be formed, 62 gram times 100, right? So you will see here, you will get a value of 80.7% here, which is our second answer here. Okay, so this is the way that you do this particular question.